Hello everyone, welcome to New Wave Coaching Classes for Science. This is your host Jatin. Today we are going to discuss about the second half of the name of the chapter, that is about chemical equations. But before that, let's revise what we have discussed in the first lecture. In the first lecture, we discussed about the chemical change, a change which involves a new substance is formed which is not reversible. That change is called a chemical change. And a reaction which involves chemical change is called a chemical reaction. With this, we also discussed about some of the examples like rusting of iron, burning of magnesium in air, reaction of zinc with hydrochloric acid, and lead nitrate and potassium iodide reactions, right? And then we also discussed about the characteristics of a chemical reactions, that how we can come to know that the reaction has proceeded, and that the main four characteristics were change of temperature, change of color, change of state, evolution of gas, and also we talked about formation of precipitates, right dear friends? So today we are going to discuss about chemical equations, right? So let's understand what is a chemical reaction. Now if we talk about the first reaction we discussed in the previous lecture, that is burning of magnesium. If we have to represent that reaction in any form, the first thing that comes to our mind is a statement. And how we write it, let's see this. If we talk about burning of magnesium, we say magnesium burns in air to form magnesium oxide. So this is the statement representation of the reaction which we have discussed in the previous lecture. Now if you see, at the moment there are the number of things in the beginning and the number of things at the end of the reactions are less. If they are more, then this statement could be a little bit longer, right dear friends? So to make it short, what we can do, we can write a name reaction. And how to write a name reaction? Let's see that also. We say magnesium burns in air. Obviously, and anything burns in air, the reaction of that substance is always with the oxygen. And we say it is magnesium oxide. Now if you see, the statement is lessened little bit. It means we have shortened the formation of the, you can say, whatever we have discussed, that is the statement, right? What we have done, we have shortened the statement when we write that thing in the form of name reaction, right? Again I say here in the beginning, whatever the things we have in the beginning, they are also called as reactants, and whatever the things which are formed, they are also called as products. So now I will be talking about reactants and products only. If you see, in the beginning of reaction, the number of reactants were less and number of product is also less. But if we have a bigger reaction, if we have more number of reactants and more number of products, again you can see this reaction can be more cumbersome, it can become more longer. To again shorten it, what we can do, we can write these things in the form of symbols, right? So in the form of symbols when we write, then how we can write, let's see that also. So the symbol of magnesium is Mg, plus symbol of oxygen is O2, and whatever the thing is formed is MgO. Right dear friends? Now if you see this thing, this is much smaller than the previous one, right? That is, if you talk about a word equation and a chemical equation, there is a lot of difference. So chemical equation basically helps you to shorten whatever you are writing about a chemical reaction, right? So what you can say about a chemical equation. Now we talk about definition of a chemical equation. So a chemical equation, we can say Now, what do you see? These are the symbols. Whose symbol? Symbols of the reactants and products which we have taken in the reaction. So we can say a chemical equation is basically a symbolic representation of a chemical reaction. So we write it as it is a symbolic representation of a chemical reaction. Right, friends? So this is what we call as chemical equation. Now we go a little bit further. Right? If you see this chemical equation, there is something weird about this equation. Let us understand what is the weird thing in this. So I write the equation once again. Mg plus O2 gives MgO. If you remember in your class 9, you learned about the atomic masses and the molecular masses of different elements and the compounds. If we talk about the atomic mass of magnesium, it is 32U. And the atomic mass of oxygen atom is 16U. It means if I multiply it by 2, it becomes 32U. Right? And if we talk about magnesium oxide, the molecular mass of magnesium oxide is basically, if we talk about magnesium, it is 12. Sorry, this is 24. Here also 24. And plus 16, it becomes 40U. Right? Now, you see here, if I talk about the total atomic mass, total mass of the reactants, if I see the total mass of the reactant, it is basically 56U here. And the total mass of the product is 40U. Now, these things are not equal. Why? There is some reason behind this. Now, what we have to do? Let's talk about the law which we discussed in class 9, that is the law of conservation of mass. Now, according to law of conservation of mass cannot be created nor be destroyed in a chemical reaction. Again I repeat, according to law of conservation of mass cannot be created nor be destroyed in a chemical reaction. But if you see the reaction on the board, there is a difference of mass in the reactants and products. Now, why this has arisen? There could be some reason. The reason is this, that if you see carefully on the both sides, that is on the reactant side and the product side, the number of atoms of the different elements are not the same. If you see magnesium, here it is one atom, here also it is one atom. But oxygen, it is two atoms on the left side and one atom on the right side. Since these are not equal, we call this kind of chemical equation as unbalanced chemical equation. So this is basically an unbalanced chemical equation. Right, friends? So this is an unbalanced chemical equation. Now what we have to do, we have to satisfy the law of conservation of mass. So to satisfy the law of conservation of mass, we have to balance this equation. Now how we can balance? Basically what we have to do, our main motive will be to balance the number of atoms of each element on both sides. Right? So what we can do? Let's see here. If we talk about magnesium oxide, magnesium plus oxygen forming magnesium oxide. Now if you see, the number of atoms of oxygen on the left side is 2. Now I want that on the right side also there should be 2. So what I will do? Should I write 2 here? No, because if I write 2 here, it will be the formula of magnesium oxide becomes wrong. Can I write 2 here? No, I cannot write 2 inside also, because magnesium oxide is a formula of a compound and no number can be entered inside it. So what can be done? What I have to do? What will I have to do? Then what I will do? I will put a 2 in front of magnesium oxide. So what will happen because of this? Because of this, the number of atoms of oxygen are balanced. But But a problem arises again. What problem arises is, what if I put a 2 in front of magnesium oxide, then the number of atoms of magnesium also increases and they also become 2. Now earlier the magnesium was balanced on the both sides. There was one atom of magnesium on the left side and one atom of magnesium on the right side. But now what has happened now? It is only one atom of magnesium on the left side, but it has become 2 atoms of magnesium on the right side. But there is no problem. So what we can do? We can put a 2 in front of magnesium on the left side. So this way we can balance a chemical equation, and this is basically a balanced chemical equation. Now we can verify this if it is balanced or not by calculating the total mass of the reactants and the products on the both sides. Right? So if you talk about magnesium, the atomic mass of magnesium is 24, and if you multiply by 2 it becomes 48. Now 48 plus 32, this is basically, on this side it is 80U. Now if you talk about the right side, magnesium oxide, the molecular mass was 40. Now if I multiply it by 2, this 2 means it is a multiplication. So if I multiply 2 into 40, it becomes 80U. It means on both sides, the atomic mass or on both sides, the masses of the reactants and the products are equal. That is why this is a balanced chemical equation. And you can also say, if the question comes, why we need to balance the chemical equation? We need to balance the chemical equation to satisfy the law of conservation of mass. Now the question, if you see this equation, it was a simple equation. I have done it this way, but there is some way of balancing a chemical equation. Let us see how we can balance a chemical equation. In the beginning, you will have to follow a long method of balancing a chemical equation, but as you practice more equations, then you can directly do it as I have done in this question, right? So I take an example. Of iron reacting with water to form Fe3O4 plus H2. Now, there is a very weird thing about this Fe3O4, because if you remember in your class 9th, you learned that the valency of iron is either 2 or 3. But if you see this, it shows that the valency of iron is 4 here and the valency of oxygen is 3. But it is not like that actually. See, whenever iron reacts with oxygen, we don't know which valency it is used. Right? It means when iron reacts with oxygen, it can form a compound with oxygen with a valency of 2 also and with a valency of 3 also. It means the compound can be FeO also and Fe2O3 also. So what we do, we combine both of them mathematically and we write it as Fe3O4, right? You can write any of the formula, you can write FeO also, you can write Fe2O3 also, and you can write Fe3O4. All the 3 formulas are correct, there will be no wrongs, right? But if it is given that the valency of iron has to be used 2 or 3, then accordingly you will make the formula, otherwise it will become wrong. Since it is not specified which valency is being used, so that is why we have written Fe3O4. Now the question, how we can balance this equation? So for that, what we do, we write LHS and RHS. Means the left hand side and the right hand side. Now the first step is to write the symbols of all the elements being used in the reaction, right? So the symbols are Fe, H and O. So these are the 3 things which are being used. Now the next step is number of atoms of each on the left side also and on the right side also. And if we see on the left side, the number of atoms of iron is 1, hydrogen is 2, oxygen is 1. And on the right side, the number of iron atoms are 3, hydrogen atoms are 2, and oxygen atoms are 4. Now, if you see, only hydrogen atoms are balanced on both sides, but iron and oxygen atoms are not balanced. It means what we have to do, we have to balance the number of atoms of iron and oxygen on both sides. So for this, what we can do, if the number of atoms of iron on the right side is 3 and this side is 1, how can I make 1 as 3? I can't add 2, but I will have to multiply it by some number. So what I do, I multiply by 3. So I can write here 3Fe. Right? Now, how can I balance oxygen? This is 4 here and this is 1 here. So, what I will have to do, I will have to multiply oxygen by 4. But I can't write 4 here. So, what I will have to do, I will write 4 in front of H2O. It means I will write 4H2O. Next, on the right side we have not done anything, so the equation remains same. There will be no change. Again, we write the LHS and the RHS. We write the symbols of all the elements on the both sides. Now, what we have done, initially we have balanced iron and oxygen. So, iron and oxygen we have balanced, it means both sides, the number of atoms of iron and oxygen are same. So, I write the same number of atoms, iron 3, 3, oxygen 4 and 4. Now, if you see hydrogen on the right side is 2. But as we have put 4 in front of water, the number of atoms of hydrogen have changed on the left side and they have become 4 into 2, 8. Now, here my iron and oxygen are balanced, but hydrogen is not balanced. Initially, hydrogen was balanced. Now what we have to do? It is 8 here, it is 2 here. Now I have to make this 2 as 8. So I have to multiply this 2 with some number and that number would be 4. So if I multiply 2 by 4, it becomes 8. It means on the right side, in front of H2, I will write a 4 and my equation will become something like this. 3Fe plus 4H2O gives Fe3O4 plus 4H2. So this is my balanced chemical equation. Right, dear friends? So this was all about the chemical equation, the unbalanced equation, the balanced equations, law of conservation of mass, and how we can balance the chemical equations. In the subsequent or the coming lectures, we will be discussing about the different types of reactions. More things, you can practice these questions more, and if you want the you can say solution of the question answers in your book, then you can go to the description section and you can click the link and you can find the solutions of the question answers of the in-text questions of your chapter 1, right? So this is from my side. Hope you have enjoyed my lecture. If you have not understood anything, you can just go and watch again. This is your host signing off. Goodbye and take care.